Well, here we are in Chapter 8, Hypothesis Testing. Hypothesis testing is extremely important. It's something that we're going to be doing for the rest of the semester. Section 8.1 goes over the framework of how it is written down, what is it that you're supposed to do. Here's the main idea. Somebody says, hey, did you know that adults sleep an average of 8 hours a night? And you think to yourself, I don't think that's true. So you go out and randomly select 40 people. You find out they average 7.2 hours of sleep per night, and the standard deviation 1.2. So that's definitely less than 8 hours a night. But is that enough data to refute the person that said it's going to be 8 hours a night? Well, that's the main idea of this section. So, as I just mentioned, these things are set up in a very specific way. Certain things that you need to write down, pictures you need to draw, etc. So let's get started on that. First of all, you write down the claim. So somebody will make a claim using less than or equal. So one of these 6 symbols. So you write down what they said. The mean equals 8. Then there's an important thing called the alternate hypothesis, H1. And the alternate hypothesis says, well, you know, guys, 6 cases, that's a lot. Can we just narrow it down to 3 cases? So that's what the alternate hypothesis does. Notice that over here, none of these have equals. This doesn't have equals, this doesn't have equals, and this is actually the opposite of equals. So H1 doesn't use any of the equals. Then there's a very easy one, and that is the null hypothesis, which, no matter what, it always uses equals. All right, an important note with H1. So if the claim already has something that doesn't have equals, so if the claim already has less than, bigger than, or not equals, then use the exact same thing for H1. If H1 has less than or equal, you use the opposite, which is bigger than. If it has bigger than or equal, you use the opposite, which is less than. And if it has equals, you use the opposite, which is not equals. So here's some examples. So these next 3 examples will basically show the 3 possibilities of writing down these things. So at least means bigger than or equal to. So the claim is that the mean is bigger than or equal to 42. H1 needs to be the opposite of that in this case, because this one here has an equal, so you have to use the opposite in this case. And H sub O always minds its own business and just puts equals no matter what. Example number 3. The proportion is over, so that means greater than 80%. So we would write that as a decimal 0.80, and then over means bigger than. And since this doesn't have an equals, H1 can stay the same. And for the 4th one, the standard deviation is, which means equals, 15. So the claim would have that sigma equals 15, and then because the claim has an equals, H1 has a not equals. All right, then draw the graph. So we did this in Chapter 6 and Chapter 7, so there isn't much new here. So which table do you use? Well, when it's about proportions, that is Z, table A2. For means, that is T, table A3. And for standard deviation, it's chi-squared, table A4. In Chapter 7, we always used 2 critical values because we were making confidence intervals which have a left tail and a right tail. In hypothesis testing, it doesn't have to be that way. But good thing we've got our friend, the alternate hypothesis, will tell you what to do. So with this one, alternate hypothesis would have this arrow pointing to the right. That means it's right-tailed test. So the picture would look like this. It would only have one right tail. And then whatever alpha is, you'd put that on this side. So for example, if it said use 95% confidence, that means alpha equals 0.05. So 0.05 would go in this red shaded area. If H1 said less than, that means shade to the left. So whichever way the arrow is pointing, it's telling you which way to shade. And in this case, because the critical value is on the left, it would be negative. And then not equals means it's a two-tailed test, so the picture would look like this. Okay, for this example, find the critical value using 98% level of confidence. So subtract 98% from 100%, that's 2%, so alpha equals 0.02. And then test the claim proportion is at least. At least means bigger than or equal to 0.50. So the claim is bigger than or equal to. H1 can't have an equal, so it's going to have to be less than. Myself, as soon as I put that left arrow, then right after that, or just after that, I then write down that it's a left-tailed test. Null hypothesis is equals, and alpha equals 0.02. So since this is about proportions, oh, I forgot to draw my picture. There, I drew my picture. Since this is about proportions, use the Z, or table A2. And because it's on the left, we need to use the negative. Then look through the middle of the table until you can find whatever's closest to 0.02. And that would be this 0.0202 is the closest. Then look to the left, and it says it's going to equal negative 2.0. Look to the top, it's going to be negative 2.05. There's the critical value. All right, on to the next part. So at the beginning I said an example where somebody said that people sleep 8 hours a night. So when can you tell that they're telling the truth? When are they lying? Or when can you just not be sure one way or the other? That's the conclusion. So let's say that the picture looks like this. If the test statistic, and we'll do the formula for that in a little while, but if the test statistic lands on the right side, you definitely did prove something. If it lands on the left side, you definitely did prove something. And when I say prove something, I mean you can make a conclusion. Yes, they're telling the truth. No, unfortunately, they were not telling the truth. So you could then say, okay, reject. So the claim that P equals 0.5 or whatever the claim was, it's false. Then, if it lands anywhere in the middle, that means you cannot conclude one way or the other. You don't have enough evidence to prove that they're telling the truth. You don't have enough evidence to say that they're lying. In that case, we say fail to reject. In other words, we did not reject them, and we're not able to prove anything. And you can just say that statement like that. We're not able to prove anything. Okay, now let's put all the pieces together. So, the claim is 50% of people feel that they are optimistic. That's a pretty optimistic view. Out of 130 people interviewed, 68 said they're optimistic. And then test that claim using 95% level of confidence. So the claim said that it's 50%, so that means P equals 0.50. This has an equals, so this cannot have an equals. So that means it's going to be two tails. H sub O always have equals. And since we're using 95% level of confidence, alpha equals 0.05. So I draw the picture, shading in the two tails. Because alpha equals 0.05, if you cut that in half, it would put 0.025 on one side and 0.25 on the other side. Then it was n equals 130 people. 68 said that they are optimistic. So if you divide those two, it's actually 52.3%, or as a decimal, 0.523. Then look up the critical value. Since we're talking about proportion, that's going to be table A2. And I find it easier to just look up the negative one, and whatever that number is over here on the left, it'll be the same number but positive on the right. So look through the table and look for what's closest to 0.025. So 0.025 is actually right here. I just found it because it's inside this little rectangle. Then look to the left, and it says it's going to be negative 1.96. Oh, sorry, negative 1.9. Then look to the right, and it's going to be a 6. So the critical value is negative 1.96 on the left and 1.96 on the right. Now for the last part of it. Next, we find what's called the test statistic. And this next formula is really a part of the next section, but I'm just going to go ahead and show you right now. So you would do this little formula, type that into the calculator, and you get a 0.526. A 0.526 on this graph would land approximately right here in the middle. And when it lands in the middle, we did not prove anything. Fail to reject, we are not able to prove anything. And then the last part is, what can the calculator do for me? So in that last one, I did the calculation myself for the test statistic. I did that little formula. You can actually have the calculator do that part. If you just go to Stat, and then Tests, scroll down and find one proportion z-test. And as you can see, it's got the different tests for the different chapter 8, 9, 10, 11. If you, hey, wait a second, I was talking about you. And anyway, so they're all here in this list. But right now we would use this for section 8.1, and then 8.2 is also about proportions. Then you just type in the information. This would be, so this symbol right here is saying what's P when you look at H sub O. So it was equal to a 0.5. Then X was 68 people out of 130. This line right here is saying, what do you see in H1? So this number comes from H sub O. This comes from H1. And then, unfortunately, there's a little black bar right there. But under that black bar, it says calculate. So you put calculate, and then it tells you Z equals 0.526. And you can do that part instead of doing the formula. All right, that's it for section 8.1. I'll see you back in section 8.2 soon. Bye.